right, so welcome back to part 2 of session 3.1. Again, we're doing the finding the slope of a tangent line to a graph at a point. Now, I want you to take a look at the directions for these two problems. The first one asks us to find the equation of the tangent line. So we weren't done when we got to here. We had to do more. This one just asks us to find the slope. So I don't need to do any of this business here. I'm done once I get done with that limit. Okay? So be careful when you're working these problems that you're reading the directions and you're answering the question that has been asked. Because if the problem asks you to find the equation of the tangent line and you just type in the slope, you're not done. And if the problem asks you to find the slope and you're typing in the equation of the line, well, you've done too much work and you're going to get it wrong. So make sure you're answering the question that is being asked. Okay? All right, so by definition, the slope of the tangent line is going to be the limit as delta x approaches 0 of f of x plus delta x, f of c plus delta x minus f of c divided by delta x. Okay? And for this problem, c is -1. Remember, c is the x coordinate of the point that you care about. And f of c is +2. Remember, f of c is going to be the y value of the point that you care about. Okay? Those two right there. Plugging everything in, I get then that we're looking at the limit as delta x approaches 0 of f of -1 plus delta x minus 2 divided by delta x. Now I'm going to do a substitution. I'm going to substitute here. I'm going to put the 1 plus delta x into the function. So I still have the limit. It is still as delta x is approaching 0. Nothing's changed there. But now I have to do -1 plus delta x squared plus 1 minus 2 over delta x. Okay? This whole piece right here is that. Okay? This minus 2 is just that -2. Okay? Now I'm going to expand all of that mess out, clean everything up, do some algebra. So I have the limit as delta x is approaching 0 of 1 minus 2 delta x's plus a delta x squared minus 1, okay, minus 1 divided by delta x. Okay. What's going to happen there and there? Those are going to cancel, and I'm going to be left with the limit as delta x approaches 0 of delta x times -2 plus delta x divided by delta x. Now, I want to just notice something about this. At this stage right here, right, after you cancel anything that'll cancel, everything in that numerator better have a delta x in it. If there is a term left in your numerator without a delta x, get out your eraser and start over. You have made a mistake. This approach will absolutely always result in this step having the entire numerator factorable by delta x. The reason being is we need this to show up in the next step, because what is this? Well, this is the hole in the graph that we can then ignore and take the limit of what's left. And when we do direct substitution on what's left, we get a limit of -2, or that the slope of tangent line is -2 at the point -1, 2. Remember that the slope isn't -2. The slope is -2 at that point, because somewhere else on that curve, the slope is going to be different. Okay? Hey, do you think there'll be anywhere else on this curve that will have the same tangent line slope? Well, our curve is a parabola that is opening up. I think there's only going to be one place where it's going to be a -2. So I don't see anywhere else. But if I had a curve that wiggled a bunch, like if I had something like this, do you think there could be a couple of places that have a -2 as a slope? Like maybe a there and a there, right? So just keep that in mind, because those are the kinds of questions that are coming. Right now we're just finding these slopes, but later they're going to ask us more complicated questions about these slopes. Okay? All right. All right. Here is a third type of problem. All right, so our job is to find the equation of a tangent line. So we have to just find the slope and then find the equation of a line. Here's the problem though. They only give us the x-coordinate of the point that we care about. They don't tell us what the y-coordinate is there. Or in terms of the language of the limit, we know that c is 3, but we don't know f of c. Okay, so how are we going to find f of c? Well, we literally have to grind it out ourselves. So if we plug in a 3, if we do a substitution x for 3, we have 9 minus 6 plus 3. 9 minus 6 is 3. 3 plus 3 is 6. So f of c is 6. Okay? So my job is to find the equation of the line that is tangent to the curve at the point 3, 6, or when x is 3. All right, again, I'm not really good at this yet. I'm still learning it. So first thing I'm going to do is I'm going to write down that formula. The slope of the tangent line is the limit as delta x approaches 0 of f of c plus delta x minus f of c divided by delta x. Right? Doing the substitutions, putting in the things that I know to be true, I'm taking the limit as delta x approaches 0 of f of 3 plus delta x minus 6 divided by delta x. I'm going to figure this piece out. Okay. So that's going to give me then the limit as delta x approaches 0 of 3 plus delta x squared minus 2 times 3 plus delta x plus 3 minus 6 divided by delta x. Okay, remember, this is just that because we're using the function f of x. It's x. It is x squared minus 2x plus 3. X squared 2x plus 3. Okay. Now I need to do a whole bunch of algebra. So I'm taking the limit as delta x approaches 0 of 3 plus delta x squared is 9 plus 6 delta x's plus a delta x squared minus 6 minus 2 delta x plus 3 minus 6. Okay, now what you'll notice is 9 and 3 is 12, negative 6 and negative 6 is negative 12. Those cancel. Oops, I forgot something. It's all divided by delta x. Sorry about that. I just got excited about the numerator. I forgot the denominator. So the constant terms are going to cancel. Everything left is going to have a delta x in it. And actually, these two can be combined. So I get the limit as delta x approaches 0. 6 delta x's minus 2 delta x's is 4 delta x's. So that's going to be a delta x times the quantity 4 plus a delta x divided by delta x. Now you'll see at this point direct substitution would give us 0 divided by 0. And there's the hole in the graph. So that's the piece we'll ignore. We'll take the limit of what's left and we get a 4. And so what does that mean? Oh yeah, what am I finding here? The slope of my tangent line is 4. Am I done? Nope. This is not just a slope problem. This is an equation of the line problem. So I need to go a step further. So I'm going to use the point slope formula. the equation of a line can be found by knowing the slope and a fixed point on that curve. I know that my m is 4. I know that my x is 3. And I know that my y, or my x sub 1, and my y sub 1 was that 6? Yeah. Right. So putting this all together, I then get y minus 6 is equal to 4 times x minus 3, or y equals 4x minus 12 plus 6 minus 6. And there's the equation of my tangent line to my curve at the value, or at the point when x is equal to 3. Okay? All right. Now, these problems are the 3 basic types of the problem. There's the find the equation where they give you the entire point, the x and the y. There's the find the slope where they give you the entire point, the x and the y, the c and the f of c. And then there's the, we're only going to give you a little bit. We're only going to give you the x. You got to find the y, and then either find the slope or find the equation of the tangent line. Right? The problems do get more challenging than this. Right? But those are the 3 basic types of problems. Okay, so I'm going to end this video here because this is the last example of finding the tangent line or the slope of the tangent line, and the next video will start here with the idea of the derivative of a function. So I'll see you back here for part 3.